So in this video, we're going to go over how to set up a definite integral that represents or yields a given area. And so the key that we want to recognize is that the definite integral represents signed area under the curve, and if your function is non-negative, it's going to actually be a positive area under the curve. So in this picture right here, I have a shaded area, and the task is to set up the definite integral that represents that shaded integral, that shaded area, sorry. So what I want to notice is that the picture that I have is running over the closed interval from 1 to 4. So I'm working over a closed interval from 1 to 4. That's my A to B interval from A to B. So I'm going to need to integrate. I'm going to need to set up the definite integral from 1 to 4, from the lower to upper bound. And then it's going to be f of x dx, but what I need is the function f of x that represents this curve. I look at that curve and I recognize it's a line, so it's a linear function, which means the function is going to have the form mx plus b, where m is the slope of the line and b is the y-intercept. So when I look at this curve, what I want to notice is that it's going up 2 and over 1, so the slope appears to be 2. So it'll be 2 times x plus the y-intercept. The y-intercept is 3, so it's 2x plus 3. So there's my function f of x that's under which I'm finding the area. So the definite integral that represents the shaded area, the area under the curve, is going to be the function, which is 2x plus 3, times dx, which is just the width of a rectangle. And then we're integrating from 1 to 4. So there's the definite integral representing the area under that curve. So on this screen, when I look at this, I have a shaded area right here. And it looks like that area is adding up to 9. And I want to set up the definite integral that represents that area. Again, this time it looks like I'm running from 1 to 4 again. So it's going to be the integral from 1 to 4. And it's going to be f of x dx. So I need to know the function that models what appears to be a downward opening parabola. So I'm going to need to think back to pre-calculus and pre-calculus skills. I know that the toolbox function is x squared for parabolas. So I'm going to get f of x equals, I see where the vertex is. The vertex is at 3, 4. And on the toolbox function, the vertex for x squared starts at 0, 0. So in terms of function transformations, my parabola has been moved 3 units to the right and 4 units up. It's also been reflected over the x-axis. So I need to reflect a parabola over the x-axis. It's going to be x. I have a shift of vertex shift 3 units to the right, so it's going to be x minus 3 squared, the minus 3 giving a shift of 3 units to the right, and then plus shift the toolbox function x squared up 4 units. So again, I'm using function transformations. If I list my vertical reflections, I see that I reflect over the x-axis. So I need the negative sign here for the reflection, and then shift 3 to the right. So that's the minus 3 inside there. And then the other transformation that occurred is shift of up 4. I know there's been no vertical stretch or compress, because from the vertex I go down 1 over 1 to get to the next lattice point. And if the next lattice point occurs in that position, it means there was no stretch or compression applied to the parabola. So the definite integral is going to be the integral from 1 to 4 of my function is the opposite of x minus 3 quantity squared plus 4 dx. So the key in the homework is going to be to remember what your toolbox functions are for the different types of functions, and then you're going to need to build the function represented in the graph and then set up the definite integral using that function that represents the area under the curve.